This video we're going to look at topic 68, section 1, topic 68, example 1, where we solve a system of linear equations. So what is the solution of the system of linear equations? And they give us two equations where we have x plus 2y equals 3 and x minus 2y equals 4. So a system of linear equations is a set of two or more equations using the same variables, and the solution of a system of linear equations is the set of all ordered coordinates that simultaneously make all equations in the system true. So there could be multiple solutions to a system. For this specific system, there's only going to be one solution, but it is possible to have multiple solutions. So the first thing they ask us to do or suggest is that we sketch the graph of each equation to estimate the solutions and then solve algebraically. So what I'm going to do is, in the form that these are in, this x plus 2y equals 3 and x minus 2y equals 4, I can't really sketch those, just looking at them the way they are. So what I'm going to do is I'm going to put them into y equals mx plus b form, and that'll give me a slope and a y-intercept, and that'll give me a decent starting point on how to graph this. So I would subtract x from each side. 2y would be negative x plus 3. And then I would divide everything by 2. So y would be equal to negative 1/2 x plus 3 halves. So that gives me a y-intercept of 3 halves, or 1.5. And my slope would be negative 1, 2. So I would go down 1 over 2, down 1 over 2. So we don't need to be perfect here. We just want to get something kind of accurate, because we're looking for a sketch to estimate the solutions. So my line would look something like that. Alright, so that's for the first one. Now the second one, we're going to do the same thing. I would subtract x, so negative 2y equals negative x plus 4, and then divide by negative 2. Sorry, those are negative 2's. So y would be equal to negative divided by negative is going to give me a positive 1/2 x, and then positive 4 divided by negative 2 would be negative 2. So I have a y-intercept, right, of negative 2, and my slope would be rise 1, run 2. So 1, 2, 1, 2, and 1, 2. So my second line, second linear equation, when I'm graphing it, would look something like this. So I know that my solution is going to be somewhere around here. Now remember, this is a sketch, so the solution, approximately, so x is somewhere between, or actually let's not phrase it that way. Let's make a little statement on this. So we're going to say that x is between 3 and 4, and y is between 0 and negative 1, right? Because this is kind of where our solution falls, is within this little grid here. Right. Now we might not be terribly accurate. Hopefully we sketched it pretty well, but that'll give us a good idea if our algebraic work is accurate. All right, so next part of this is I want to solve these, right? So I have this 1/2 x minus 2 is equal to y, and I have this piece over here. The negative 1/2 x plus 3 over 2 is equal to y. And what I can do is I can actually set those pieces equal to each other, right? Because, I mean, y is equal to y. Everyone would agree with that. So I can change one y to be negative 1/2 x plus 3 halves. And I can make the other y come from the red equation, which would be 1/2 x minus 2. And now I have an equation that only has x as my variable, so I can solve it for x and then go from there. The first thing I'm going to do is get rid of my fractions. I'm going to multiply everything by 2. So 2 times negative 1/2, get negative 2x, plus 6 over 2 equals 2 over 2x minus 4. So all I did was take that 2 and distribute it in. There are other ways to do this, but let's just go with that. So we reduce this or simplify, and we now have no fractions that we have to worry about. All right, so I'm going to move the x over. Remember, this is 1x. So I get negative 2x plus 3 equals negative 4. Subtract 3. And then you would just solve this how you would solve a regular equation. So x is equal to 7 over 2, which, based on our graph, kind of makes sense, right? 7 over 2 is 3.5, and that is between 3 and 4. Now, because I drew that by hand, the intersection is not going to be perfect, but 7 over 2 is a good estimate based on our, 7 over 2 is the exact answer. Our graph shows that that could be probably pretty accurate. So x is going to be 7 over 2. To solve for y, I now need to take this 7 over 2 and then plug it in anywhere I can for an x value. I can plug it into either the highlighted blue equation, the highlighted red one, or either of my originals. I'm going to choose to plug this into the y value. So I'm actually going to use this equation here. So I'm going to say y is equal to 1/2 times 7 halves minus 2. Might not have been my best choice, but we'll work with it. So y is equal to 7 over 4 minus 2. All right, and then y would be equal to, I'm going to change that right as a decimal to make it work a little bit better for us right now. That's going to be 1.75. So we're going to do 1.75 minus 2, and that is going to be negative 0.25, but I will convert that back to a fraction. So y would be negative 1/4. And again, if I check with my graph, if I look here, a negative 1/4 seems like it would be pretty accurate, right, based on the sketch of my graph. So my solution is a coordinate point. So I'm going to say 7 over 2 and negative 1/4. So the whole idea here, we solved this using substitution, and we used a sketch of a graph to estimate the solutions. You could use substitution, you can use elimination, you can use graphing methods. There's a lot of different options, but the idea we're looking at here is that a system of linear equations, when you have two lines, if they intersect, they're going to have one solution, and that solution will be a coordinate point with an x and a y value. All right, and that is it for this video. You can try the try it problems, see how you do, and go from there.